Greetings, dear Professor Chin. My name is PHIN. My group member in this evidence analysis project is Abigail, Sim Setak, and also Lee Pei. In 20th of May 2024, a fire broke out in the Serenity Art Gallery, destroying the gallery's art collection. However, traces of fire accelerant was discovered in the scene, indicating possible arson instead of an accident. A bottle of greasy fluid was found in the rubbish dump few meters away from the scene. Joey Sim, the in-charge investigator, collected evidence from the scene and had targeted few suspects. The truth of the case will be further updated and validated once the lab analysis is done.
Forensic chemistry is a study which is a combination of organic and inorganic analysis skill sets and techniques that contribute to the investigation in arson, serology, toxicology, as well as other criminal and civil cases. Forensic chemists under a fire and arson division will involve in investigations of the fire scene to determine the fire's origin and spreading pattern, identify the potential ignition sources and the characteristic of the burn material which might cause the spreading of the flames, as well as analysis for accelerants. In most cases, the main objective of the analysis is to determine whether the cause of the fire was accidental or deliberate to aid in the resolution of a lawsuit or prosecution. The identification, characterization, and quantification of the evidence will be carried out using the modern equipment. In this case, FTIR and SEAN were selected to analyze the evidence collected, which are unburned cloth, burnt cloth, and a bottle of greasy liquid which was suspected to be an accelerant to start the fire. ATR FTIR was used for the analysis. The setting was 32 scans at resolution of 8 wave number. Each spectrum was corrected with empty diamond as background. Each sample was run for 5 replicates in different positions. Peak detection was done using the Omnic spectroscopy software, and the results were collected in transmittance. The spectra was combined in the same axis for comparison.
Scanning electron microscopy, also known as SEM, is one of the laboratory analyses used to analyze the evidence collected from the scene. Firstly, both the samples were cut into small pieces. Then, the cut samples were positioned on top of the aluminum plate and placed firmly with carbon tape. Then, both samples were coated with platinum before sending into the SEM.
This figure shows the FTIR spectra of burnt cloth sample as shown in the blue line, unburnt cloth sample shown in the red line, and diesel shown in the green line. According to the FTIR spectra, the peaks between 2008 to 2009 and at around 1007, 1004, 1002 and at 700 are slightly higher in burnt cloth sample as compared to the unburnt cloth sample. Those peaks mentioned correspond to the peak of diesel spectrum, which proves that the presence of diesel is found in the burnt cloth. The increase in adsorbent peaks of burnt cloth sample was not obvious as the burnt cloth sample was not analyzed quickly after being exposed to diesel. The remaining diesel present in the cloth had been evaporated, leading to a reduced concentration of diesel residue. Therefore, the detection of diesel in burnt cloth sample was weak.
Under a 50 times magnification using the SEM, the nylon cloth exhibits a woven structure with individual fibers entwined regularly, based on the images obtained for the untreated cloth. So the cross-section of the fibers appears cylindrical and flattened. So natural nylon is characterized by longitudinal grooves and a slightly rough texture on the surface of the fibers, which can clearly be seen at a magnification of 1000 times. When examined under 200 times magnification under the SEM, the nylon material torched with an accelerant exhibits a unique morphological change. There are numerous shattered, brittle fragments of charred fibers that can be seen. However, at higher magnification of 1000 times, the burned fiber surface appears uneven and rough with numerous fractures and fissures, indicating thermal degradation. On the fiber surface, various residues that are most likely the accelerant remains can also be seen and are visible.
As a conclusion, both SEM and FTIR results prove that the burnt cloth sample was ignited with fire in the presence of diesel as the accelerant. SEM results reveal that the regular structure of the cloth fiber underwent morphological changes in the burnt cloth sample. FTIR results confirm that the burnt cloth sample's spectrum matches that of diesel.